drying rates. So by putting in microwave, it can actually speed up the drying process. Basically, in terms of equipment setup, you just need to combine a microwave, this microwave resonant cavity, okay, into the freeze dryer. Okay, so throughout the drying process, intermittently you activate the microwave. Okay, it's by this researcher, and they are from China. Okay, so in terms of findings, they actually discovered that you can see there is a reduction in drying time of about 31 hours. Okay, and then there is a very fast drying rate, okay, of about 3635. Okay, 3635 gram per kilogram hour. Okay, and then the SEC, okay, specific energy consumption is 15.77. Okay, so if you look at this table, okay, for freeze drying, the drying time is 41 hour. Okay, but for freeze drying, microwave drying, okay, the drying time is cut short, okay, by 31 hours. So 41 hours compared to 10 hours. Okay, also you can also see that microwave drying in this case show the highest drying rate. Okay, but nevertheless, the freeze dry microwave dryer, okay, is still showing much higher drying rates compared to the conventional freeze drying. Okay, so also in terms of specific energy consumption, freeze dryer is the highest. Okay, so by using the more advanced drying technique, okay, you can actually reduce the specific energy consumption. Okay, so this show that by incorporating microwave into the freeze dryer, you can improve the drying rate, and also at the same time improve the SEC, okay, the specific energy consumption. So the freeze drying process will become more efficient and energy saving. Okay, so this is the product they dry. This is okra, or ladies' fingers, or in Malaysia we call bende. Okay, so this is from the freeze dryer. Okay, this from the freeze dryer. This is the fresh. Okay, and then this the microwave vacuum dryer, and then this the freeze dry microwave vacuum dryer. Okay, so from here you can see that the color, if I compare with this, okay, if I compare with this air dry is the worst. Okay, you see the color maybe it's not as nice as the fresh or the freeze dry, and then the shrinkage is very high. Okay, the one using freeze dry microwave still look quite the same as the original. Okay, and then is comparatively is still quite close to the freeze drying. Okay, so in terms of product quality, it can actually still preserve the appearance, the color, and then also the nutritional content. Okay, next I go to infrared freeze dryer. Okay, like just now, they are using microwave assisted freeze drying. Okay, so here we can also use infrared assisted freeze dryer. Okay, so basically the concept is about the same. Okay, you just need to put the infrared radiator into the drying chamber of the freeze dryer. Okay, so from in this experiment, you can see that, okay, by these authors, researchers, you can see that they're using wavelength of 2.4 to 3 micron. Okay, heating intensity at 5 kilowatt per meter square. And then the quartz glass emitter is positioned 15 centimeter above the apple surface. Okay, these are the dry apple. Okay, this is the conventional freeze drying. Okay, this is the infrared freeze drying. Okay, from here you can see that there is a reduction in drying time. Okay, from 22 hours, almost 1 day, to 14 and 12 hours. So the reduction in freeze drying time is about almost 46%. Okay, or maybe can be even close to 50%. Okay, if they fine tune the parameters. Okay, the drying parameters. Okay, in terms of energy output, you can see here, this is freeze drying. Okay, and then this is the infrared drying, infrared freeze drying. Okay, so energy consumption can be reduced. Okay, and this help to improve the efficiency during drying. So this show that microwave infrared is they are quite conducive in promoting the drying rate. Okay, and also help to reduce the energy consumption. Okay, in my university, we also have this infrared dryer where we use this for the bird nest drying. Okay, if you see this bird, okay, this bird actually build the bird nest, and then this bird nest can be consumed. Okay, after it's dry, it can be consumed. I think in Indonesia you also have this product. Okay, because Malaysia, Indonesia, we actually export bird nest to China. Okay, so this is how the dryer looks like, and so the bird nest will be put here. Okay, and then here you can see the infrared. Okay, this is the infrared. So the energy, okay, the infrared energy will be emitted to the surface of the product. Okay, and then this is the bird nest product that we produce. Okay, because we want to make sure the bird nest product is sufficiently dry, and then it's also free from contamination. Okay, because infrared heat is quite hot. Okay, quite hot, and then can penetrate deeper into the product. Okay, next is the ultrasound assisted dryer. Okay, so in this case, they are using a hot air dryer with the ultrasound device. Okay, if you know about ultrasound is actually a very strong, you can say it's a very strong vibration. Okay, it's like a vibration. Okay, and then this vibration will actually help to remove the moisture in the food product mechanically. Okay, there is no heat involved. Okay, maybe there is some heat due to the cavitation process. Okay, but mainly the removal of the moisture is through mechanical. Okay, so in this dryer, they are actually using this ultrasound transducer. Okay, number 9. Okay, number 9 is the ultrasound transducer. So this ultrasound transducer is attached to the drying thread. Okay, number 11 is the drying thread. Okay, so during the drying process, the ultrasound is generated intermittently, okay, to help the drying process. Okay, so from here you can see that the researcher reported that 3 different levels of ultrasound, okay, using air temperature of 40 until 70 degrees C. Okay, the increase in both the applied acoustic power and temperature give rise to significant reduction in drying time. So about 13 to 44% reduction in drying time. So meaning that by using ultrasound in hot air drying, it can help improve the drying rate. Okay, and hence the moisture can be removed easier. Okay, and then significant difference was observed, especially on the effective diffusivity. Okay, meaning that the effective diffusivity is higher, and the drying process is faster, and then the mass transfer rate of moisture is happening at a much faster rate. Okay, so this shows that ultrasound is also able to help improve the drying process. Okay, next is called the pulse combustion drying. Okay, this dryer is a bit different from the normal hot air dryer because this is actually using pulse combustion. Okay, so meaning that there is a combustion process that generates the heat and then transfer to the drying vessel. So in this case, this is a spray dryer. Okay, this is how the pulse combustion works. So you have this chamber, this pulse combustion chamber, where you have fuel, okay, and air. Once you put the fuel and the air inside, the igniter will ignite the mixture. So there is a big explosion. Okay, there is a big explosion. Okay, this explosion, okay, because of the fuel and the air, okay, will produce the heat. Okay, and then this heat will be supplied. Okay, this heat will be supplied into the drying chamber. Okay, in this case, this is a spray dryer. So you can see the spray here from the atomizer. So the atomized droplet, the liquid droplet will be dry by the heat from this combustor. Okay, this pulse combustor. Okay, so pulse combustion is a periodic ignition and extinguishing of the combustible mixture of fuel and air. Okay, the benefit of this is the heat is very high. So the heat is very high, it can dry droplet very fast. Okay, because in spray drying, you need to dry the droplet very fast. You cannot dry too slow. Okay, so you need something that can generate a high heat at a short time. So in this case, they're using the pulse combustion drying. Okay, this is egg white powder. Okay, so they spray egg white powder in the pulse combustion dryer. So you can see that the one using the pulse combustion dryer is looks nicer. Okay, egg white powder supposed to look white. Okay, of course, but the one using the spray dryer is a bit yellowish. Okay, it's a bit yellowish, meaning that there is some color change during the spray drying process because the heat is not as high as in pulse combustion drying. Okay, so there is a color change during the drying process, but unlike in pulse combustion, okay, it can actually show better color. Okay, also because there is lesser oxygen. Okay, there's lesser oxygen in the pulse combustion dryer because oxygen is used up to become the exhaust heat. Okay, the exhaust heat has no oxygen, so it actually help to reduce the oxygen environment in the drying chamber. Okay, next is we come to this one, absorption drying. This is by Prof. Jaini. So it's a collaboration work between Prof. Jaini and myself. Okay, we did this like I think in 2016, 15 or 16, if I'm not mistaken. Okay, so in this dryer, the drying is through the release of absorption heat. Okay, absorption heat is like Adsorbent is like the desiccant. Okay, in the lab you have this green color particles where normally you will put with the beaker or with your sample so that to keep the product dry. Okay, the blue color thing. Okay, so that one is a type of adsorbent, or in the lab you maybe call it desiccant. Okay, this adsorbent, if in contact with water, it will actually generate heat. Okay, and then this heat can also be used to produce the dehumidified air. Okay, so that is why you have the dehumidified air here. After the inlet of the surrounding air, okay, to the desiccant. Okay, A and B is the desiccant or the adsorbent. Okay, adsorbent packing. Okay, after that you have the heated dehumidified air or dry air. Okay, and then this is supplied to the drying chamber. Okay, to carry out the drying process. So from this study, actually, we found that by using zeolite, okay, zeolite is the adsorbent. Okay, the drying rate is actually better than without zeolite. Okay, so with zeolite, the drying rate is much better, and then is compared to the one without zeolite. Okay, so if you look at this these two graphs. Okay, next we also apply this in onion drying. Okay, so in 2017, one of Prof. Chinese student actually used this in onion drying. Okay, so we have successfully dried the onion and also observe better drying kinetics throughout the drying process. Okay, this is also another research we did on egg white. Okay, egg white for carrageenan. Okay, is the seaweed. Okay, next I want to introduce you to this dryer. This also another dryer we developed in Nottingham. Okay, it's called the heat pump dryer, and we have used this to dry cocoa, jigu, salak, and ganoderma. Okay, I believe you know about salak. Okay, in Indonesia, you have a very good and delicious salak fruit. Okay, ganoderma is the mushroom. Okay, is they call lingji. Okay, I'm not sure you have heard about this or not. Okay, anyway, the drying process is also very unique because this is using heat pump. Okay, what is heat pump? Heat pump is like the air condition unit at your house or in your office or in the school. Okay, the air condition unit, you have the condenser and also the evaporator. Okay, the evaporator will generate the dry air. Okay, the dry air for your drying process. Okay, so if you see here, the evaporator will actually generate this dry air. Okay, and then supply to the drying chamber. Okay, and then the condenser will actually works to exchange the heat through this heat exchanger system, so that you can recover the latent heat from the outlet air. Okay, the outlet air. This is the after drying. You have the outlet air. Okay, this outlet air actually is recycled back to here. Okay, so that this evaporator and condenser unit will actually make, you can say, recycle back the latent heat, okay, to be used for the next drying process. Okay, all we can see this dryer, this the compressor. There is the evaporator here. Okay, and then this part is the drying chamber. Okay, so this is the heat pump dryer. So what result we have discovered was this dryer able to improve the flavor. In fact, we can improve the flavor of cocoa beans, quite similar to the good quality one from Ghana. Okay, better retention on bioactive ingredient, and then also better texture, color of the fruit product. Okay, like jigu and salak fruit, after we dry, we actually can get the texture is much better than the hot air dry product. Okay, as well as the color. Okay, so we have so many dryers. Of course, it comes with advantages and limitation. Okay, so advantages is it can help to reduce energy, enhance quality. So energy consumption, we get some saving from the energy consumption. And microwave can penetrate into greater depth. Okay, cavitation from the ultrasound could facilitate removal of strongly attached moisture. So it can help to remove the moisture better. Okay, infrared radiation can be focused. Okay, so you can actually zoom in the infrared radiation so that you don't waste the energy, and lesser oxygen concentration in pulse combustion dryer. Okay, and absorption dryer can actually give you the dehumidified air, which is drier, less lower in RH. Okay, compared to the normal dry air. Okay, but there is a limitation. Okay, non-uniformity of microwave field, and this can create some hotspot. Okay, ultrasound energy transfer in gas, okay, is more difficult than liquid. Okay, infrared is not suitable for too large dryer, okay, because of the limitation in volumetric heating, okay, unlike microwave. Okay, noise and vibration in pulse combustion dryer. Okay, the pulse combustion dryer is very noisy, okay, because of the combustion process. And then vibration is quite strong. So it might give some mechanical stress to the dryer. Okay, of course, all these things is not cheap. Okay, when you use the modern technology, it's still quite expensive. Even in current, current economics. Okay, so concluding remarks, selection of drying system is important to ensure we produce a high quality and premium product. Okay, modern dryer should be efficient, not only in terms of drying time, but also energy aspect. And industry and academia, we should continue to drive R&D and also innovation. And the ultimate aims is to meet the demand for better efficiency and the needs of consumer. Okay, because we have more and more new consumers, especially the younger generation. They have good knowledge about food, so their demand from the food product will be high. Okay, so we have to know how to meet this demand. Unless unlike in the old days, we only produce normal dry food, and everyone has no problem about it. But nowadays, consumers are getting well educated and more health conscious. Okay, so this concludes my presentation. Thank you very much. And I am open for question and answer. Okay, and then I will pass back the session to Dr. Al-Bari.
Okay, thank you so much, Dr. Ching, for the nice presentation. It is so I cannot imagine if what is that? So I can imagine the equipment in your lab. So there is something like what is that? The innovative equipment of drying equipment, I think, in your lab. So
Okay.
so I just curious about this one. So is this in your lab? So are you built by yourself?
Mm-hmm. Only the heat pump dryer and the infrared dryer are in my lab. Of course, we don't have the workshop to build ourselves. Okay, but we engage the the company. I mean the third party to actually build for us. But of course, we supply the technical specification, the design, and the capacity to them. Okay, so the third party company will actually build this for us.
Oh yeah, so you collaborative with the company to
Yeah,
build
yeah,
this one, right? Oh yeah.
yeah.
You have equipment, but I have salak. So it is good match, right?
Yeah, yeah. We actually have a lecturer that used to do salad drying. In fact, you met her before during the conference.
Oh, so from the Lampung or from whose the salax collected from?
No, I mean the researcher that did salad drying from my university. Actually, she came to Semarang before for
Oh,
the
I
conference.
see. Yeah,
Yeah,
yeah, yeah,
yeah.
yeah, 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 yeah. I can
But
remember. Oh,
the salak fruit we got from Malaysia. Uh,
oh,
because
Malaysian
to
salak.
yeah Malaysia salad, which is smaller. I think the Indonesia salad is the bigger one.
Oh yeah, because Undip located is not so far from the Salak region,
Ah,
so you
okay.
can find a Salak in the several varieties
Oh,
with
okay,
the
okay.
several taste also. Yeah,
Mm.
so next time let me bring Salak to
Okay, okay, okay.
Nottingham
Thank you.
without seed, without seed.
Yeah, without
Yeah.
seed is nice. It's
Yes.
nicer.
Yeah, so we should go for quarantine if there is a seed inside of the bag, right?
Yeah, yeah, yeah.
Yeah, difficult. Yeah, so let me open the question from the student who knows.
Okay, okay.
One or two question will be provided to you.
Mm-hmm.
So student, if you want to ask a question, silahkan. So let me, what is that? There is a chatting from
Oh, okay.
Ardian Sah Pratama. Yeah, so Ardian Sah Pratama asking about the pulse combusting drying.
Oh, post combustion
Pulse
drying. Okay.
combustion drying. Yeah, it is using the combustion to rid of the liquid. Yeah, just he wonder that what is that? If it is good for texture of the product. So what do you think about this one, Doctor?
Okay. I think I can see the question on the chat box. Actually,
Oh yeah, yeah, yeah. Nice.
post combustion drying, the heat is very the temperature is very high. So if you use this for solid food product, might not be suitable because the temperature is very high. So normally for solid food product, you want to dry at a low, not saying lower, but not so high temperature. Okay, so that you want to keep the color and the texture. But post combustion drying is more suitable for like spray drying process. Okay, because in spray drying process you need high temperatures. It can be more than 120, 140. But in normal hot air drying of food, solid food, you don't go to 120, 140. But in spray drying, yes, you go to 120, 140 because you want to dry the liquid droplet. Okay, it's like a tiny rain. Okay, like hujan, tiny rain. You want to dry it very fast. So that is why pulse combustion drying is more suitable for the powder product. Uh-huh. So I hope that answered the question. Okay, I think
Yeah.
I can see a
The
second
another chat.
question. Yeah.
Yeah, the chat from Darisman. So, what do you think about this one? It is about the
Okay,
natural energy.
hybrid drying is one of the drying technology use natural energy to process or be the heat source. That's forgotten because its inefficiency. However, the developer must be encouraged. How do you respond for this case? Yeah, actually, hybrid drying should be, in my opinion, should be encouraged because the conventional drying technique. Okay, even like generation 3 drying technique, like freeze drying is a very long process. It's not efficient. And then not many company or not many producer can can is I mean not many of them afford to use this technology because the not only because of the price but also because it's too long, the drying process. So if they use this with let's say microwave freeze drying, okay, so they cut down the drying time, so it's more attractive for the company or the producer or the industry to use, so that they can achieve the economics, okay, or they can achieve the efficiency that they want. So actually hybrid drying is currently quite popular. Many universities are actually doing studies on this, okay, especially in microwave. Okay, it can be microwave freeze drying or microwave spray drying. Okay, it can be also sometimes you can also have spray freeze drying. Okay, freeze drying but inside a spray dryer. Okay, because is to improve the drying rate, because you freeze dry droplet is faster compared to you freeze dry a bigger food product or a bigger volume of solution. Okay, I hope that answered the question.
Okay, so it is very nice because right now, recently, we also should think so much about how to make energy efficient. So it is good, I think, for us to challenge in the near future research. Okay, so the next. So can you still see the chat, Dr. Hitchinglik? It is about the appropriate drying method. Appropriate drying method. So what do you think about this one, Dr. Hitchinglik? Hello, so could you hear me? Oh, so Dr. Hitchinglik right now is out. Sorry for this one. So we
Yes, the discussion section.
so let's
Yeah.
let wait for Dr. Hitchinglik to enter this room again.
Okay. Yeah.
Hello.
Hello, so welcome back.
Yeah, I
Sorry.
don't know what happened. Okay, back to the
Sorry.
yeah, it's okay, no problem. Back to the question,
Yeah.
how to select the best dry.
They showed
Yes.
similar data.
So
We cite
uh, to determine
that
the
data,
appropriate drying method
and
for the
if other
product,
people
and then
are
to
like
produce the premium quality. What do you
opposite
think about this
data,
one, Dr.
we
Hitchinglik?
just cite
Hello,
research
doctor.
something
So
according to our data.
I cannot hear you. So let me mute all,
Okay.
then unmute again. So can you hear me? Oh, Dr. Hijenglik is out again. Oke, thank you Rido. Terima kasih Rido sudah bertanya. Ini satu lagi tentang Pak Darisman. Mas Darisman juga sudah, Mas Ardiansah. Oke. So, if you still have time, so you can ask not only in this session. So we will find the he again in the maybe next week.
Hello, sorry, I think the
Hello.
my
Yeah.
internet line is not very good. Sorry,
Oh,
sorry.
no problem. Yeah.
Okay, so I mean,
Yeah.
let me continue with the answer. So it depends on
Yes. Okay.
product. I mean, if you want to go to very high quality, then you might want to consider hybrid drying using freeze dryer. Okay, but if your product there is no problem with there is no strict quality requirement, then you can go for the normal hot air. But of course, at the end of the day, you need to know what is your target consumer. Okay, some product if it's meant for, I mean, if the quality requirement is not high, then there is no need for you to go for the freeze drying or microwave freeze drying. But of course, it all depends. You are dealing with liquid product or solid product. Then liquid product, you can go for spray drying. But spray drying also depends. You want it to just spray dry or spray freeze dry. Or sometimes if you don't want to use spray drying, you can also use drum drying. Okay, so the how to decide which one is the best and which one suitable, actually it depends on many factors.
Okay, so I think this is a good response upon the question from Ardiansah. Okay, so doctor, thank you so much for today.
Oh, thank you for your time.
Because recently, yeah, at the time right now is 2 o'clock, so hopefully this not disturb you while delay 5 minutes
Oh, it's
from
okay, no
two
problem.
o'clock. In Indonesia still 2 o'clock.
Okay.
In Malaysia 3 o'clock. Okay.
Yeah, 3
So
o'clock.
thank you
Yeah.
so much. Yeah, Dr.
Okay, thank
Hitchinglik,
you.
thank you so much, and see you again in the
Okay.
next time and next opportunity. We are very happy to have class with you.
Okay. It's
Okay,
my
so
honor
yeah.
to present. Yeah. Okay.
Okay, so let's close our session and see you again in the next
Okay, sure.
time.
Okay, see you
Okay,
again.
thank you.
Bye-bye.
Bye bye. Thank you so
Bye.
much. Okay.
Thank you.
And all of the participants, thank you so much for attending today. And hopefully we can see all you in the next future. Thank you so much. Bye bye.
My